All right, crew. I'm trying this for the first time and just seeing if this is going to help you. Just a little video casting and just show you what you need. Excuse me. Um, so, um, as we did this morning, um, we are basically calculating and plotting rates of reaction from raw experimental results. IB wants you to be able to do this. So, catalase is an enzyme. It's an intermediate enzyme that breaks down hydrogen peroxide, H2O2, into harmless substances like water and O2, which are then recycled back into the cell and used however they are needed. O2 being the main reactant for cell respiration, which we know a little bit about. So if you imagine, those of you that weren't here at the beginning of class this morning, if you imagine a bucket filled with a neutral solution, and the bucket has 1 gram of beef liver in it, and in beef liver you have the enzyme catalase. It's in all living systems. And when the cells in the beef liver go through cell respiration and cell processes and metabolic reactions, hydrogen peroxide is produced. So then, because of hydrogen peroxide being produced and it being poisonous, the hydrogen peroxide needs to be broken down. So therefore, catalase facilitates this. Now, the study was that at 1 minute intervals for 10 minutes, we weighed the remaining solution. So you have a bucket full of this neutral solution where this liver is, and the bucket is sitting on top of a scale. And for every minute, that scale is being weighed, or a data point is being recorded. So after 1 minute, the solution weighed 44.41 grams, and then 2 minutes 43, and then 42.85, and so on and so forth. So you are going to take that initial data and you are going to calculate a mass decrease. Now, of course, if we go to 0, we don't have a mass decrease from 0, and you don't have a rate from 0. So this first column is going to be non-applicable or null, or doesn't matter. And then subsequently you will calculate the mass decrease at 1, 2, 3, all the way to 10 minutes. Now, you see it is a mass decrease of grams here. Please convert to milligrams here and do the same thing across in the second row. Now, the third row is the rate of mass decrease, which would be milligrams per second. So you need to calculate what the mass decrease in milligrams per 1 second, and you can figure that out if you have data points per 60 seconds. Let's go to the third slide here. As it reads, please show one sample calculation for the rate of mass decrease over time. When you post process data, you are expected to post a sample calculation of whatever, however you're processing. You're going to graph your change in mass over your change in time to show the rate. Okay. Remember that as a guideline, your x-axis is always your independent variable, whereas your y is your dependent variable. Calculate the overall rate. Analyze with those two questions. What happened as time increased? And then why do you think that happened? So this is not homework at all. It was more of an experiment of, well, don't do the homework. Don't do it as homework, but we'll do it in class. But I wanted to send this to you because I want to understand if this type of thing is helping. I'm looking and doing video podcasting for my classes, in the future, and I would appreciate your feedback. If you have any questions, please comment on the classroom because I'm going to post it there. And also, please give me, please give me positive feedback. I kind of need it these days. So I hope this helped, and I hope you have a good night. And don't worry about that.